Hey everyone, today we're going to talk about section 1.3 on rates of change and behavior of graphs. So I've gone ahead and written out our first example here so we could jump right into it. Since functions talk about, or rather, since functions represent how output quantities change with input quantities, it's natural for us to ask about the rate at which these values are changing. So here I've given us a function, c of t, in table form, which gives the average cost in dollars of a gallon of gasoline after the year 2000. Now, if we were interested in how gas prices have changed between 2002 and 2009, we could compute that the cost per gallon had increased from $1.47 to $2.14. Let me find my mouse here so I can scroll down. There we go. So the cost has increased from $1.47 to $2.14. This is an increase of 67 cents. While this is interesting, it might be more useful to look at how much this price has changed per year. So there are 7 years between 2002 and 2009. So if I find how much this price has changed per year, then I'm finding the average rate of change over these 7 years of the cost of gasoline. And I get that 67 cents divided by 7 is, let's see, this is about 0.096 dollars. I already wrote the dollar sign, so I don't have to write dollars here. Per year. So on average, the cost of gas increased by about 9.6 cents a year. Now, obviously, this doesn't necessarily tell us the whole story, as gas prices went up before they went down at the end here. But for computing the average rate of change, we're not necessarily concerned with what's going on in the middle. We're just concerned with what's going on at these endpoints, or the endpoints of whatever interval we're going to choose here. So a rate of change describes how the output quantity changes in relation to the input quantity. The average rate of change between two input values, let me actually make this a little smaller. There we go. The average rate of change between two input values is the total change of the function values or output values well, I said function values first. So function values, and then in parentheses, I'll put output values. Divided by the change in the input values. Another way of writing this, we can write this as an equation. So average rate of change is change in output divided by change in input. We might represent this as delta y. These deltas represent change, divided by delta x, or y2 minus y1 divided by x2 minus x1. So using the cost of gas function from earlier, let's find the average rate of change between 2007 and 2009. So in 2007, the cost of gas was $2.64. In 2009, the cost of gas was $2.14. So in 2007, the cost of gas was $2.64. In 2009, the cost of gas was $2.14. So if I want to find the average rate of change here, I can do $2.14 minus $2.64 divided by, I'm just going to do 9 minus 7 instead of 2009 minus 2007. This is negative 0.50 divided by 2. And here I'm going to get negative $0.25 per year. So this negative average rate of change means that the cost decreased, right? So this is saying that the cost decreased by an average of 25 cents per year. Let's look at using a graph. So I'm going to just write the problem, then I'll pull the graph over. Let's see. Given the function g of t, find the average rate of change on the interval. This is a closed interval, 0 to 3. So I will pull this Desmos window over. There we go. So this is our graph. The first thing that we need to do is we need to find what our output at 0 is. See, it's at an x value of 0, I have a y value of 1. And at an x value of 3, I have a y value of 4. So, let's see. How do I want to write this? This means that my average rate of change is going to be 4 minus 1 divided by 3 minus 0. This is 3 divided by 3, which is 1. We can also express average rate of change using function notation. So if we are given a function f of x, the average rate of change on the interval AB is f of b minus f of a divided by b minus a. So we can use this to compute the average rate of change of f of x equals x squared minus 1 over x on the interval 2 to 4. Here, we can just start by computing the function values at each endpoint of this interval. So f of 2, this is 2 squared minus 1 over 2. This is 4 minus 1 half. 4 is the same thing as 8 halves. 8 halves minus 1 half is 7 halves. F of 4. This is 4 squared minus 1 fourth. This is 16 minus 1 fourth. I need a common denominator here again. 16 is the same thing as 64 fourths. I subtract 1 fourth, and I get 63 fourths. So now I just tie this together with this formula, f of b minus f of a, all over b minus a. And I get 63 fourths minus 7 halves over 4 minus 2. I need a common denominator up here. So I'm going to transform this numerator into 63 fourths minus, I can multiply the numerator and denominator of the 7 halves by 2 to turn that into 14 fourths. And my denominator here, 4 minus 2 is 2. 63 minus 14, that's 49. So I have 49 fourths divided by 2, which is 49 eighths. And that's my answer here. And let's do another example. Find the average rate of change of fx equals x minus 2 root x on the interval 1, 9. Same idea here. I want to find f of 1. This is 1 minus 2 times the square root of 1, which is 1 minus 2 times 1. The square root of 1 is just 1. This is 1 minus 2. That's negative 1. F of 9 This is 9 minus 2 times the square root of 9, which is 9 minus 2 times the square root of 9 is 3, which is 9 minus 6, which is 3. Then this becomes, let's see, 3 minus negative 1 divided by 9 minus 1. 3 minus negative 1 is the same thing as 3 plus 1, which is 4. 9 minus 1 is 8. 4/8 simplifies to 1/2. And this will be it for average rate of change.